Okay, so today we're going to be learning lesson 65, which covers prime factorization, division of primes, and factor trees. Feel free to pause the video anytime you need to make sure that you copy down everything you need to in your notes. Alright, so let's start. Write this definition down for me. A factor is one of two numbers that are multiplied. So let's look at our factors of 12. One way that I like to do is I like to make a T-chart. I know 1 and 12, 1 times 12, 2 times 6 would equal 12. And then 3 times 4. So my factors of 12 would be 1, 2, 3, 4, 6, and 12. My factors of 30 would be 1 and 30. And then I look what comes after 1 and 2 will go into 30. So 2 times 15, 3 times 10, and then 4 will not, but 5 will. 5 will go into 36 times. So my factors of 30 would be 1, 2, 3, 5, 6, 10, 15, and 30. Do you notice how I'm noting them in numerical order? My factors of 9 would be 1 and 9, because 1 times 9 is 9. Also, I'd have 3 and 3. So this does have 3. The 3 factors of 9 will be 1, 3, and 9. Now, notice down here I have a 5. So let's look at our factors of 5. Factors of 5 would only be 1 and 5. Now, we call that something special. That is known as a prime number. And a prime number is a counting number greater than 1 whose only two factors are 1 in itself. So make that note of what a prime number is for me in your notes. Make that note of that definition. And so we just noted 5 is prime because the only factors of prime are 1 in itself. I can't multiply any other number other than 1 and 5 to get 5. 3 is also a prime number because 1 times 3 times 1, that's the only two numbers I can multiply to get 3. 13 is also a prime number. The only factors of 13 would be 1 and 13. Now we're going to go ahead and pause the video, write this down. Prime factorization is a way of writing a composite number as a product of its prime factors. And make sure to write the prime factors from least to greatest. That way it's easier for you to read and easier for you to find what you need to find here in a little bit. So pause the video, write that down for me. So you've just written down the definition of prime factorization, and we're going to be recording our prime factors using prime factorization for what we find from factor tree. So a factor tree is all the composite numbers can be formed by multiplying prime numbers together. You can do this by making a factor tree. So here, we're going to make some factor trees. A factor tree with 4 would be 4. What two numbers can I multiply to get 4? And notice we do not use 1 for these. And when you get to a prime number, you circle it. Now 1 is not prime because 1 in itself is just itself, so it does not work for prime. So 2 times 2. So I'm going to circle 2 is prime as 2 is prime. And also 6, if I make a factor tree for 6. I know what two numbers can multiply together to get 6, 2, and 3. When I get to a prime number, I'm going to circle them. So it'll make more sense here in a minute when we try the next section. So now I've already done 9 for you. What two numbers can I multiply together to get 9? 3 and 3. And remember, when we get to that prime number, we have to circle it. So I circled my 3 and my 3. Okay, so let's make a factor tree for 8. So I'm going to ask, what two numbers can multiply together to get 8? It could be any numbers you want. I'm going to say 2 and 4. Now notice 2 is a prime number, so when I get to a prime number, that's the end of my tree, so I stop. But 4 is not prime. 4 is composite. I can also multiply what two numbers to get 4? 2 and 2. So when I get to a prime number, both of these are composite. Now how would I write this using prime factorization? I would say 8 equals 2 times 2 times 2. Because I have 3 2's, 3 circles, and each of those circles are represented down at the bottom. Now if I were to multiply it out, 2 times 2 times 2, it would equal 8 back up at the top. So let's do 20. What two numbers can we multiply together to get 20? Okay, I'm going to say 2 and 10, because 2 times 10 equals 20, what they both stem from. Now, 2 is a prime, so that's the end of the circle for there. 10 is not prime, 10 is composite. So what two numbers can I multiply together to get 10? 2 and 5. Now, 2 is prime and 5 is prime. And how I write this using prime factorization, I would say 20 equals, and I put them in least to greatest order, 2 times 2 times 5. So make sure you have these trees written down on your paper and have the prime factorization with them. And I'm going to go ahead and do how would I write prime. 9 using prime factorization would be 3 times 3. So now let's get into some bigger numbers. Now I'm going to do 40. Actually, I'm going to let you do 40 here in a little bit. Let's do 100 together first. So 100. I'm good at 100 as the top of my tree. So I'm going to think, what two numbers can I multiply together to get 100? I know 2 and 50. So I'm going to, 2 is prime, but 50 is not. If it's not prime, we have to keep going. What two numbers could I multiply together to get 50? I know 2 and 25. So 2 is a prime number, but 25 is not, so we have to keep going. What two numbers could I multiply together to get 25? 5 and 5, because 5 times 5 is 25. So when I write this prime factorization out, I'm going to put them in order from least to greatest. And I'm going to say that number that I originally started with, 100 equals 2 times 2 times 5 times 5. Now what I want you to do is I want you to make sure you have this 100, or a factor tree for 100 written down, pause the video, and then I want you to do 40 on your own. After you've done 40, replay the video and check and see if your factor tree, if your prime factorization is the same. Now you may use different factors to get there, so check your prime factorization, which is right here at the bottom. Check your prime factorization for 40 with mine. Now here is the factors that I used to find my prime factorization for 40. You may have used different numbers. You may have multiplied different things or had a different order. That's fine, but this is what matters right here. 40 should equal 2 times 2 times 2 times 5. Now, you may have, your tree may look different, but this should look the same. I'm going to teach you another way to be able to write prime factorization is using division of primes. So you can divide composite numbers by prime numbers to factor. Now how you do it, now make sure you may want to make this note in your notes about how to do division of primes, and for sure write division of primes. How to, you divide the smallest prime number, divide by the smallest prime number, then keep dividing until your dividend, I'm sorry guys, it's not your dividend, until your quotient, the answer is 1. Sorry about that. So how to, you divide by the smallest prime number, then keep dividing until your quotient, the answer is 1. So why don't you watch me do this for the first one, because it's kind of different. This on factor trees we start from the top and work our way down. On division of primes we start at the bottom of our page and we work our way up. Not necessarily the bottom. We start lower and we work up. So what's the smallest prime number that will go into 36? Well, 1 is not prime, so 2 is a prime number. Will 2 go into 36? Yes, it will. So how many times will 2 go into 36? 2 will go into 36 18 times. Now I'm going to ask myself, what's the smallest prime number that will go into 18? Well, let me tell you, if it's an even number, 2 is your smallest prime number. So will 2 go into 18? It will. 9 times. So now I'm going to divide by 9. Divide into 9. My dividend changes every time. So in this case, I know 9 is not an even number. So 2 will not go into 9 evenly. But 3 is a prime number. Will 3 go into 9? Yeah, well, how many times? 3. So now, 3 will go into 3. How many times? 3. So what am I left with? I'm left with 1. What I like to think is when 1 is at the top of this, it's over. So right here, this is my prime factorization. I just have to write it. 36 equals 2 times 2 times 3 times 3. So let's try that again. I know it's kind of different for you. So why don't you skip a few spaces in your notes, and I want you to write your dividend is 48, because we're finding the prime factorization of 48. So what is the smallest? We have to find the smallest prime number. And the smallest prime number that I can think of is 2. And I see that 48 is even, so I know 2 will go into 48 evenly. So how many times will 2 go into 48? 24 times. So I divide that. So what's the smallest prime number that will go into 24? 2. 2 goes into 24 how many times? 12. So now I'm dividing 12. What's the smallest prime number that will go into 12? Well, it's even, so 2 will. 2 goes into 12 how many times? 6 times. So I keep going until 1's the top of my tree. How many times will 2 go into 6? 2 will go into 6. Well, oh, sorry. I need to write that down. 2 is the smallest prime number that will go into 6. 2 goes into 6 3 times. Now, what's the smallest prime number that will go into 3? 3. So I'm left with a 1 at the top. Now, 1 is not a part of my prime factorization because 1 is not a prime number. But when 1 is the top of my division of primes, I'm finished. So when I write this out, I'm going to say 48 equals, and look, it's already in numerical order when I do the division of primes if I'm working from the smallest prime number. 2 times 2 times 2 times 2 times 3. Now, if I were to multiply this out, it would equal 48. Okay, so here's your homework tonight. Write this down in your notes and rewatch the video if you have any questions at all. Thank you.